Hi, good evening, folks. This is a video that I thought I would put together about factoring by grouping. I know this is like a super difficult concept that I think a lot of people struggle with as we're learning factoring. So I hope that in this video I can maybe like break down a couple problems, kind of show you a few different cases that you might see when you work with factoring by grouping, and then kind of give you the breakdown on how we solve the problem. Now, for a lot of people who've learned how to factor previously, right, we've learned about some pretty traditional ways, right? When we learned about quadratics, we learned maybe how to have the numbers multiply to C and add to B. We might have seen some patterns like perfect squares or difference of squares. So what this is searching for patterns, and these patterns involve a greatest common factor, okay? And so by kind of seeking out the patterns, and with a little bit of ingenuity, we're going to see we can really solve any kind of problem with factoring by grouping, okay? And so the idea here is what we want to do is we want to take our expression, we want to group it up, meaning we want to move terms around, and then we want to factor out a greatest common factor such that in the end we have two terms or two expressions that are exactly the same, and then we factor those expressions out to get our ground product. And I'm going to show you what this looks like, okay? So this is problem type 1, and I'll just take it one problem at a time. In this type of problem, no rearrangement is actually necessary here, okay? So all we're going to do is we're going to look for our GCFs, and we're going to kind of jump right into it without having to rearrange any of the individual terms, okay? So what we have is we have 8r cubed minus 64r squared plus r minus 8, okay? And so what I noticed right away here is I noticed that these two terms have a greatest common factor, and so do these. So when I put parentheses around them like this is what I call grouping, okay? And what we know from algebra is that with the associative property, it doesn't matter when I'm doing things like addition, or in this case, right, subtraction, which is really adding a negative. It doesn't matter the order that I group things in terms of parentheses, I'm always going to get the same result, okay? And in this case, it happens to be convenient because notice that these both have an 8 in them, and they have an r squared in them, right? This is r squared times r, and this is just r squared. So what I'm going to do is I'm going to factor out a greatest common factor. So 8 is the biggest number that goes into these two, and r squared is the biggest power of r that goes into them. And now when I take that out, let's factor that out. What I get is, well, what do I need to multiply this by to get 8r cubed? Well, all I have to multiply this by is r. And you can see if you distribute it, 8r times r is 8r cubed. And now I'm going to do a similar thing here, okay? So now I'm going to do, well, what times 8r squared is 64r squared? Well, if I multiply by negative 8, 8 times negative 8 is negative 64, and I don't need to put an additional r because I already have the r squared when I multiply, right? Because 8r squared times negative 8 is negative 64r squared. So I've actually given myself more parentheses than I need. Now over here, notice that I already have an r minus 8, right? And remember, if every kind of expression, or these are right monomials, they all have a factor of 1 in them, right? If nothing else, they always have a common factor of 1, okay? And so now look what I have. What I have is, notice that I have an r minus 8 here and an r minus 8 here. So by regrouping them, I've actually found that we have another common factor here, r minus 8. So there's an r minus 8 in here and an r minus 8 in here. And so what I'm going to do is I'm going to undistribute this. And to help you kind of understand what's going on here, imagine if I had this. Let's say that I called this thing, I don't know, P. And right? Well, if these were just p's, right, notice how, look, these have a common factor. What I could do is I could factor out that p. Maybe I'll show you up here. I could factor out that p. And if I did that, all I would have left is 8r squared from this piece plus 1 from this piece, okay? And it's the exact same idea, right? Because we know this is, in reality, this is not p. This is r minus 8. So this is what I do. And again, notice, did I take out 2 p's here? No, right? I only took out 1 p. And this is where it gets confusing. You see 2r minus 8s, but in reality, just like with the p's, I'm only going to take out 1 r minus 8. So here I go. I factor out my r minus 8. So what times r minus 8 would give me this? Well, I already know. It's 8r squared. And let's take a second and think about it. If I multiply r by 8, r minus 8, my apologies, by 8r squared, am I going to get this? Of course, right? We can see r minus 8 times 8r squared, right? And even if we were to distribute this, this would be 8r cubed. This would be negative 64r squared. Same thing, right? 8r cubed, negative 64r squared. I can do a similar thing here with the 1, right? This would be r minus 8, r minus 8. So what we can see is what we've done is we've taken this and we've broken it down from what was a cubic into something that's a little bit more manageable, all right? Because eventually we're going to want to make sense of the zeros of these things. In other words, what r values are going to make this original polynomial equal to 0? And here we can easily see, well, if r is 8, right, that's going to make it equal to 0. And the thing is, with cubics, there's no easy way, and it's called a cubic, by the way, because of this power of 3. With cubics, there's no easy way, okay, to solve for r and find r equal to 0, all right? Remember, with the quadratics, we have the quadratic formula, right? There is a method with the cubes called Cardano's formula, but it's not easy to pull off. It's overly procedural. And if we have methods like this, there's no real reason that we are going to go and do that, okay? All right, so now I'm going to go ahead and show you another example. So before I do this, I really recommend you pause the video now and you try to solve this one on your own. Okay, it's the same exact idea. You're going to take out the GCF. You're going to group it first. Then you're going to take out the GCFs. And then you're going to try to factor. Okay, I'm going to give a couple seconds so you can try to pause this. Try it on your own. And then I'll show you the answer in just a sec. All right, so here's what we're going to do, folks. This is what we're going to do. So look, I'm going to look at these first. Okay? So if I'm thinking, okay, greatest common factor. Greatest common factor. Not easy. This one's a little bit harder, right? But in this case, okay, so what I'm seeing is I'm seeing a 3 in here, right? 3 can go into 12. 3 can go into 21. And over here, notice 7 can go into 28. 7 can go into 49. Now, why am I using these numbers? Well, I just can see in my head, right, that 3 times 4 is 12, and 7 times 4 is 28. 3 times negative 7 is 21. 7 times negative 7 is negative 49. Okay, so there are some cool patterns there that's going to help us. So here I've got a 3 that they share in common. And now let's go ahead and try to find the biggest power of p. Look, they also have a p squared in common, right? And we'll do our factoring. So 3p squared times what is 12p cubed? It is 4p. And now 3p squared times what is negative 21p squared? Here it's just negative 7. Okay, now I'm going to see if I can get a 4p minus 7 when I take the GCF out of this one as well. So here again, I notice that I have a 7 in common because a 7 goes into 28 and a 7 into 49. There's no p here, but that's okay because I need a p on the inside as well. So if I get 4p minus 7 in here, that means I'm good. And if I'm not, what we're going to see is that's okay. That just means that I have to go ahead and maybe think about rearranging these, as I'm going to show you in a second, so I can get that common thing showing up. So let's take a look. 7 times what is 28? That's going to be 4. And again, I need the p in here as well. And now here, 7 times what is negative 49? It is negative 7. Okay, and notice how 4p minus 7, 4p minus 7. So just like with this idea here, I'm going to take the 4p minus 7 out. Okay, then I'm going to put my 3p squared. And then I'm going to put my positive 7. Okay, and at this point, we are all done. We figured it out. Okay, so again, our idea is, in this case, this is a type 1. Everything's already set up. So we group them. We find that GCF and take it out. All right, looking for specifically when we factor out the GCF of those little groups to find a factor in common. Okay, so in this case, it was 4p minus 7. In this case, it was r minus 8. Okay, so it's going to take a little bit of ingenuity. It's going to take a little bit of frustration. But I really believe if you're willing to put in the time, right? Already you're watching this video, so that's showing me you're putting in that time. You can be successful, all right? It doesn't always come easy, and that's okay, all right? So take a second if you need to digest this, and then in a moment I'm going to move on to type 2. Okay, so I'm going to come down and take a look at type 2. Now type 2, very similar in nature to type 1, okay? Here's the difference. The difference here is I can't group them right away, okay? They're not ready to be grouped with the parentheses because, let's say I try to do that, right? So if I try to group this right away, I can see that there's a 3a squared and a 3a squared that goes into both of these. But notice there's no number in common here and there's no letter in common here, okay? So what that means is that I can't just jump right into the factoring by grouping. But what I'm going to do is I'm going to use the commutative property as well as the associative property, okay? Because we remember that it doesn't matter what order you write the terms in, you're always going to get the same answer, okay? That's true with numbers and it's true with expressions. So I'm thinking about it and I'm like, okay, look, the 12 and the 4, those have a number in common. The 9 and the 3, those also have a number in common, okay? So now I'm thinking, how am I going to rearrange this? Well, what I'm thinking I'm going to do is this. I'm going to take my 12a cubed, and look, the 12 and the 4, those seem to have something in common. So I'm going to take the 4a, I'm going to move that next to the 12a cubes, and now I'm just going to scoot that negative 9a squared over and put it with a negative 3. And remember, I'm allowed to do this because the order of the terms doesn't matter. Think about if you plugged in your favorite number, like 1. If I plug in 1 here and I flip these terms around, the output's not going to change. I'm just figuring out the numbers in different order, right? So if I plugged in 1, this would be 12 minus 9, which is 3, plus 4, which is 7, minus 3, which is 4. So I'd get 4. Right? If I plugged in 1 here, I'd get 12 plus 4, which is 16, minus 9, which is 7, minus 3, which is 4. So you can see, for example, that it doesn't matter how I rearrange the terms, I'm going to get an equivalent expression. But now, look what I can do. These have a 4 in common, and these have a 3 in common. And you know what? A lot of this is about trial and error. And that's okay, because trial and error is an important problem-solving process. So let's see what we can do here. Okay, so look, now let's try the GCF strategy again. Now, these both have a 4 in them, right? So here's my first group. And observe, they both have an A in them. So let's factor out a 4A, okay? And now, 4 times what is 12? 4 times 3 is 12. Okay? A times what is a cubed times a squared. And now this one we're good because 4a times what is 4a? Well, anything times what number is itself, that number is 1. And I apologize if my ones look confusing. I like to put flags on my one. I know not everyone likes flags on there. I put a little flag. All right, now, if I can get a 3a squared plus 1 in here, when I factor out the GCF, I'm good. If not, I rearrange, and that's completely okay. So now I notice, okay, good. Well, these both have, now I got to be careful, a negative 3 in them, and no a squared, but that's okay, because remember, in my parentheses, I need that a squared to be there. So if I take a negative 3 out of here, what I get is 3a squared. And remember, because this is negative, when I distribute the negative 3 times 3 becomes the negative 9, and then the a squared shoots right on in there. And now, because this is a negative, what I put here is a positive 1, so that negative 3 times positive 1 is negative 3, and I'm good, right? Because look, the 3a squared is showing up in both. So now I take my 3a squared plus 1 out. How many am I taking out of each one? I'm only taking 1 out. This is one of the hardest parts about factoring by grouping. This is one of the most common questions I get, and it's completely understandable. Okay, but remember, I'm only factoring one thing out, right? And think about it. How many 3's got taken out? Here, only 1, right? I only took 1 3 out in total. How many 4a's did I take out? Only 1 4a came out. So similarly, only 1 3a squared plus 1 is going to come out. And now I get this final result. Okay, so if you need a second, maybe rewind, process it. Okay, that's all right. And I'm going to move on to our last, maybe you try right here. Okay, here we go. So what I'm going to do is, as usual, I'm going to ask you to try. This is going to be a type 2 problem, okay? So this is a situation where you might have to do some moving around before you group. Take a second and try it, and then I'm going to show you the answer broken down. Okay, here we go. Now remember, in type 1, we were already good to go. So sometimes you're going to be there. It's going to require some thinking. It's going to require some trial and error, and that is 100% okay. So let's take a look. So here's how, again, we're going to know if we need to do the move around, okay? So here I go. I'm going to try to do this, but notice, the P and the 2 and the 5 are already an issue. These are not having anything in common numerically, but notice that the 2 and the 6, those have something in common numerically. And go ahead and look, the 5 and the 15. So this is a good sign, right? Because I know 2 times 3 is 6, and 5 times 3 is 15. That is a good sign. So here's what we do. Remember, with that commutative property, I'm going to go ahead and I'm going to rewrite, okay? Because remember, because of the commutative property, these are exactly the same statement. So this should be 5p squared plus 15. Okay, and I apologize if I use my flag ones and my regular ones interchangeably. Sometimes I have a habit of doing that. Now let's go for our GCF. Okay, so what's our GCF? Here, 2 and 2. But am I done? No. Because what else do I have to squeak in here? Well, let's take a look. Oh, okay. Wait a minute. There's a P in there as well. So we got our 2P, right? Because this has a power of P. This has a power of P. So when I take it out, what do I get? Well, I get P squared, right? Because 2P times P squared is 2P cubed. And now I'm going to go, well, what times 2P is 6P? 3. Now, again, if I can factor out a GCF and get P squared plus 3, I'm good. Otherwise, I try it again. And that's okay, right? Remember, some people might remember when I taught the box, I said, look, there's no tricks. We're just going to do trial and error, and mistakes are perfectly all right. That is totally fine. So here I go. Greatest common factor here is 5. Notice that there's no p's in common. So I take out a p squared, and then, nice, a 3. Perfect. So now, again, the p squared plus 3, only one of them comes out, right? Just like only one 2p came out, only one 5 came out, only one p squared plus 3 comes out, and you can tell my pen has definitely seen better days, okay? And now look, 2p plus 5, okay? That's what we should have there. Okay, so again, this is factoring by grouping. And remember, we have 2 cases or types. We have a type 1, and in type 1, that's the easiest, most basic type because we're already grouped up. There's no need to move around. We're good to go. We can just take out that GCF and rearrange, as we saw here and here. However, in type 2, all we got to do is rearrange and then group and then factor out those common factors. Okay? And I really recommend, as I didn't necessarily do here, but maybe I'll add this in now, really try to put your parentheses around your groups because that is going to help you identify those groups and it's going to provide a really good visual cue to help you factor that out. Okay, so again, I hope you found this to be informational. I hope you got a lot out of this video. Just please do me a huge, huge favor. Just keep working at it, keep believing in yourself, and you can do it. All right, I put this video out to help you, so now you help me. Keep working at it. Don't give up, and tell yourself, I can do it. All right, have a wonderful evening and good luck, and let's do some math. I love math.